Hi. I didn't see you there. Well, while you're here, I'd like to tell you about one of my favorite puzzles called the Prisoner's Dilemma. This problem is an example of game theory, a strategy that is very helpful in making decisions. The Prisoner's Dilemma is a famous situation in which two prisoners are being interrogated in two different cells. We assume both prisoners are rational and that they want only what's best for themselves. So, they will always take the course of action that benefits them most. In game theory, we usually have one male and one female player so we can discuss them using the pronouns he and she. The prisoners, Fred and Mary, have been arrested for robbing a store.
Stop.
Since the two criminals were caught with the money, there is enough evidence to convict them for robbery. But Fred and Mary have also killed the owner of the store and the police lack the evidence to prove it.
Oh dear.
The prisoners will receive one of 4 sentences depending on what they and their fellow prisoner do.
Listen, Mary, I'm going to give you 2 options. First, you can confess and plead guilty. If Fred stays silent, we'll use your testimony against him and you'll go free. If Fred confesses too, we'll have enough evidence to put you both away for 10 years, a reduced sentence for your honesty. Secondly, you can stay silent. If you both stay silent, we can put you both in jail for 2 years for robbery, but if you stay silent and Fred confesses, we'll put you in jail for life because you failed to cooperate.
So if she confesses, Mary will either go free or spend 10 years in jail, depending on what Fred does. If she stays silent, she will either go to jail for 2 years or for life. So that may seem a bit confusing, but there is an easy way to break it down. We can use an outcome table. Outcome tables help us determine what the outcome of a situation will be if there are multiple variables. This table shows how much jail time will be spent by each prisoner depending on each prisoner's decision. In this case, if the prisoners make the same decision, they receive the same sentence. Staying silent will result in 2 years each, while confessing will result in 10 years each. Integer values can also be used. But to simplify it, we can use numerical values. Notice that if they both stay silent, their combined jail time is the shortest. This brings us to the third part of our problem, the paradox. Our 2 prisoners, Fred and Mary, are only looking out for themselves. So, each will make the decision that is in their own best interests.
If Mary confesses, I can confess and receive a reduced sentence for my honesty. Or I can stay silent and go to jail for life. So if she confesses, I should confess, but if she stays silent and so do I, we both go to jail for 2 years. But if I confess, I go free. So no matter what Mary does, I'm better off confessing.
This means confessing is something called the dominant strategy. So Fred should confess, right? Not quite. If we assume that both prisoners are rational, and that they make the same observations that Fred did, they may both choose to confess. But if they make the seemingly logical decision to confess, they will both end up in jail for longer than if they had stayed silent.
I confess.
I confess.
I sentence you to 10 years each. Not talking? Then we'll have to sentence you to 2 years each. And now for our fourth point, the history of the prisoner's dilemma. As I said, the prisoner's dilemma is just one problem that exemplifies game theory. An early example of game theory appears in the Babylonian Talmud, a document of Jewish law. A man has died and owes 100, 200 and 300 coins respectively to 3 separate creditors. However, the amount they receive depends on how much money the man left behind. As you can see, the outcome depends solely on how much money is left. It's not always divided equally or proportionally, it only depends on the variable. But the game theory as we know it today did not originate until 1944 when John von Neumann and Oscar Morgenstern wrote The Theory of Games and Economic Behavior. Their book focused on strategies that helped players minimize their maximum losses, which is called the Minimax solution. In the 1950s and 1960s, game theory as we know it today began to develop. with a number of strategists looking for ways to solve a puzzle, to find the best possible outcome. The Nash equilibrium was invented by John Nash as a way of looking at game theory. It involved finding an outcome where neither player could change their decision for the better. Game theory can be applied for many purposes. For example, imagine two soda companies competing to control the market. Each company wants to price their soda as high as consumers will pay, but they have to consider their competitors. Consumers may be willing to buy soda 1 if it is their only option, but they will be much more inclined to buy soda 2 if it is offered. The two soda companies will have to decide how to price their product based on their competitor's price. This strategy applies to many different businesses. Another thing to consider is how the game changes when there are more variables. This may mean more players or more courses of action they can take. What if Fred and Mary were debating whether or not to rob the store and they knew that their local police used the prisoner's dilemma on suspects? Now there are 6 possible outcomes. Outcome 1, Outcome 2, which can be broken up into 4 different outcomes, and Outcome 3. Now you know a little bit about the prisoner's dilemma. Would you confess or stay silent? Here are some of the sources I used. Thanks for watching.